Hello dear students and welcome to module 3. In this module we are going to talk about effect of current, also about electrical current and also about introduction to simple circuit. Also we will do writing bar chart and bar chart, and also you will know about grammar future tenses and grammar first conditional tense. I hope that you didn't have any problem with the first and with the second module. Let's begin our new lesson about effects of current. First of all, I hope that you remember what does it mean magnetic field and field lines. Magnetic field, this is the region about a magnetic where the force of attraction or repulsion can be detected is called magnetic field. Magnetic field around a magnetic can be detected by using a magnetic compass. Also here in my screen exactly you can see the picture of how magnetic field works. Magnetic field lines, let's talk right now about this. Exactly, magnetic field lines are the path around a magnetic along with the north pole of a magnetic compass. Needle tends to move. The magnetic field lines around a magnetic can be observed by sprinkling iron filings around a magnet. It can also be observed by moving a magnetic compass around a magnet. The magnetic field lines emerge at the North Pole and merge at the South Pole. The magnetic field lines are closer at the poles. The magnetic field lines do not insert each other. Also, how works magnetic field lines you also can see at the left picture and at the right picture of my screen. I hope that it's very simple for you. Magnetic field due to a current carrying conductor. Let's talk that's why about this. If a magnetic compass is placed near a conductor carrying current or wire, the needle is deflected. This shows that a conductor carrying current has a magnetic field around it. If the direction of the current is from north to south, the deflection of the magnetic needle is toward the east. If the direction of current is from south to north, the deflection of the needle is towards the west. Also, the magnetic field around a current carrying straight conductor is in concentric circles. It can be observed by passing a current carrying straight conductor through cardboard and sprinkling iron lines on it. Also, here you can see in my page how magnetic field due to a current carrying conductor from the left picture and from the right picture. Let's now talk about right hand thumb rule. This is very simple. The direction of the magnetic field around a conductor is given by right hand thumb rule. It states that if a current carrying conductor is held in the right hand, such that thumb points in the direction of current, then the fingers wrapped around the conductor shows the direction of the magnetic field. If we are going to talk about magnetic field due to a current through a circle loop, when current is passed through a circle conductor, exactly loop, the magnetic field produced is in the form of concentric circles around the conductor. Towards the center, the arcs of the circles become larger and appears a straight line. Also, here you can see the picture of magnetic field due to a current through a circle loop. Let's talk about magnetic field due to a current is a solenoid. A solenoid is a circle coil of wire in the shape of a cylinder. When current flows through a solenoid, it behaves like a bar magnet. The ends of the solenoid behaves like the north and south poles of the magnet. The magnetic field produced by a solenoid is similar to the magnetic field produced by a bar magnet. The strength of the magnetic field depends upon the strength of the current and the number of turns of the coil. Also, the magnetic field is concentrated into a nearly uniform field in the center of a lone solenoid. The field outside is weak and divergent. Guys, exactly this is a picture of how this construction can work. I hope it's very simple for you. Let's talk about electromagnet. A strong magnetic field inside a solenoid can be used to magnetize a piece of magnetic material like a soft iron when placed inside the coil. Such a magnet is called an electromagnet. If electric current is passed through a wire wound around a piece of soft iron, it behaves like a magnet. Such a magnet is called an electromagnet. One more position. Force on a conductor carrying current in a magnetic field. Electromagnetic Ampere suggested that if a current carrying conductor produces a magnetic field and exerts a force on a magnet, then a magnet should also exert a force on a current carrying conductor. Example: if an aluminium rod is suspended horizontally by a wire between the poles of a horse-shoe magnet and current is passed through the wire, then the aluminium rod is displaced, and if the direction of current is reserved, the direction of displacement also reserved. The force extended is maximum in the conductor of perpendicular to the magnetic field. Guys, for today that's all about our new lecture, and I hope that you can everything understand about this. After this lecture I attached some documents. Please do it as your homework. See you soon. I wish you good luck.